Hello everyone, my name is Dr. Pablo Guillino. I am the founder of Klepsydra Technologies, and I'm here to present how parallel data processing can be increased so that it's more deterministic, higher performance, and therefore being able to increase robustness of guided navigation and control software. So as a context, I want to explain one thing. There are big problems with data processing on board, especially because of the hardware and the sensors have evolved substantially, while software has remained more or less the same for the last couple of decades. This has one main issue, which is that CPU tend to max out quite quickly with moderate amount of data. We're not talking about very large amount of data, just with little amount of data, the CPU will already become maxed out. This has important consequences for space, as you can see here. Recurrent failures due to software, lack of access of Earth observation data, etc. Satellites struggling to meet power requirements. So other industries have faced the same problem, especially financial industry, and they solve this problem in a very successful manner by using what is called log-free programming techniques. High-frequency trading and other super fast and super successful software solutions for investment industry has shown that this can be extremely useful. And all this is based in one particular little instruction called compare and swap, which enables you to atomically modify a piece of memory in the computer. This is done in something called busy wait. Basically, you try to set the value. If it's not possible, you try it again. Once it's finally possible and the data is consistent with the compared value, then you move on into the next instruction. Compare and swap has been around for a while, since the early 70s by IBM, but they didn't really become popular until Maurice Hurley in early 90s created a derived instruction called the so-called atomic operations. You might have heard of atomic Boolean, atomic integer, etc. They're much more popular than the compare and swap. So how does this work? So instead of having a standard log mechanism, which as you might know, you wait for a resource to be free. While you are waiting, your thread is being suspended. When the resource is free, the thread is awakened. And all this process of suspending and awakening requires something called context switch. These context switches are done by the operating system and are quite processing consuming, power consuming, and more importantly, they are not deterministic at all. On the other hand, log-free programming, that I show here with an image of an aircraft trying to land. The runway is busy, therefore what the plane is doing is flying around and continue trying once more, so basically a busy wait, as I mentioned, until the runway is finally free and can land. So that means there have been no no context switches, therefore there are two main benefits to that. More determinism and less power consumption for these kind of operations. So at Klepsydra, we have been working with this for a while now, and I'm here presenting you one particular benchmark we have done with these techniques. We have done a very simple case where we use several sensors producing data and stuffing them into a queue. On the other side of the queue, there is a consumer listening when it stores data in memory. When a certain number of reached, is serialized and stored to file. So quite simple case, yet very much close to many of the things that satellites are doing on regular basis, like telemetry or whatnot. So we compare a traditional mutex-based or log-based queue with one of our log-free ring buffers, and the results are here. So in the first case, this is a Xilinx board with a CAN bus for receiving data from the sensors running Linux. We did this last year in collaboration with Logspace. And as you can see at the bottom left chart, you can see the Klepsydra, the log-free techniques we are using not only increase the performance up to 20%, but also, as you can see, the reduced choppiness show that the determinism is much higher. In fact, you can see in the chart on the bottom right. Top right shows how the processing power is much less in a solution like this log-free. And again, this curve is completely linear, which is quite important in terms of processing power. Similar results, more recent, last month from the Coban GR716, famous microcontroller, and in this occasion running Artems as operating system, so a real-time operating system. Some of you may wonder how it's possible that in a real-time operating system we can achieve the results shown here. Well, log-free is also quite beneficial in this scenario. So still context switch is not something that real-time operators are immune to. Again, left column, consuming power, Klepsydra, blue line on the bottom side, so quite power saving. Left column, data throughput, Klepsydra on the top, blue line, linear, so producing data, consuming data at the same rate that the data is arriving. Forget about under low in this case. This is quite linear and growing with the consuming power, the processing power of the computer. So as a conclusion, log-free programming techniques can reduce these problems of data processing, consume less CPU, less latency, higher data throughput, more importantly, increasing determinism. Main cons of this solution are the extreme difficulty in programming these techniques. I mean, there are only so many developers that have real skill in order to work with that, especially rare in the space sector. There is another small issue with the processor, but because not all processors have cast instruction, but I would say 99% of the market, even in the space sector, is already covered, so not really a big deal. We have gone beyond that, and we have been doing testing in the area of vectorization and pipelining. So we have been comparing standard vectorization techniques like OpenMP and with a log-free pipeline. Why we're doing this? Because one other area of data processing on board is to have processor-intensive algorithms like strong compression algorithms, machine learning, Kalman filters, etc., navigation algorithms. All these tend to use a lot of resources while processing and are usually quite good candidate to vectorization. But we say, okay, let's say if we can do something completely different in the area of pipeline. And you can see here some results in a Raspberry Pi, a bunch of steps of matrix multiplications, less CPU again, higher throughput. So this software also is quite valid in these areas. So we're talking about something that can be used for machine learning to reduce consuming power, to have much better compression algorithms, to have better vision navigation in space. So these are the applications for space exactly. So vision navigation is one of them. More data processing on board, better control loop, therefore increasing the overall mission. In case of self-observation, we're talking to be able to reduce the consuming power quite a lot, and at the same time give faster access to data from Earth, better compression algorithm, machine learning, etc. In terms of telecoms, the benefits are quite obvious. Increasing throughput means increased revenue. And on the other hand, you could also consider using some more advanced AI solutions for space, like cognitive radios. At Klepsydra, we have been working with these techniques for a while, and we have an SDK that is quite powerful, as you can see in this chart here, quite increasing performance and data processing. There is a solution open source for that. If you guys are interested, you will see it in the last slide. We have also another product for AI on board. We have been using this kind of pipelining techniques with substantial success. As you can see, comparing to the leader of the market, Klepsydra performed extremely well in this area. Much higher throughput and much better energy consumption. So what awaits us in the future? We're working especially in the area of hardware acceleration, like FPGAs and GPUs. The state-of-the-art research shows that these kind of techniques combined with log-free memory synchronization can substantially increase the performance. I mean, we're talking about order of magnitude increase in data processing with this kind of acceleration and log-free programming. And this is our main goal for the future. So as a conclusion, log-free programming techniques are extremely beneficial to space, faster data processing, reduced power consumption, determinism, and the benefits for space are extremely clear. So Earth observation, navigation, and telecom. Okay, so that's all. Thank you very much. Bye-bye.